Right then guys, we're back at the grinder and as you can see I've broken it. I don't know why I do this. I looked at it when it first came and I thought that's totally brilliant, it's not going to need anything doing to it. And if you watched my last video on this grinder you'll have noticed that I was having some issues getting the motor to run, couldn't get it to work with my phase converter, thought it was my phase converter potentially. Thought it could be this switch box potentially, and it maybe still could, it's still not perfect, but took the belt off the pulley on the motor, wired everything back up again, press go, motor spins up absolutely fine. This started it 2 or 3 times, no bother at all, doesn't get warm, motor spins really freely, no problem at all. So that tells me that it's probably not my phase converter that's the issue. I was then spinning the end of the spindle with a wheel on it, and obviously it's not attached to the motor at that point, so there's no drag coming from the belt or the motor or anything, and it was still really, well, not really stiff, but it was quite stiff to turn. So you can see where that's led me. So once I got to that point, I then thought, well, there's something obviously clearly not quite right with this spindle, so we'll just we'll take 1 or 2 bits off and just have a bit of a look and see what's happening. And of course you can see what's happened, I've took it all to bits completely. So if I just start the motor up now, I've powered it back up. That switch is still a little bit dodgy, but that's it running now. You can hear the motor, really quiet, it'll run for ages and ages like that, no problem at all, doesn't get hot, doesn't trip itself out, and if I hit it to turn it off, that motor just runs down so slowly, which says it's not dragging, there's no drag in there, so I'm happy the motor's good. This isn't brilliant, it's still struggling, so I might need to do something with that switch, but I think the motor's fine. Alright then guys, on a bit of closer inspection and a bit more disassembly, it's starting to make a little bit more sense. So the information that I'd got was off lathes.co.uk's website, which clearly states that at the front end on this machine, on the later models that didn't have the bronze bearings in, there was 2 angular contact bearings opposing each other behind the wheel at the front end that were loaded up as an assembly, and at the rear end behind the belt was a single deep row ball bearing, ball race. What's actually the case, and this is why I thought I couldn't make this understand this, I'd only disassembled the front and found the single deep groove ball bearing at the front. So this is the front, this is where the wheel goes at this end, that end's where the belt goes at the back end. Actually on further assembly that's exactly what we've got, but it's 180 degrees opposed to how lathes.co.uk says it is, so I'll contact them and just let them know. I don't know whether they're still on the go, but their information's not correct. So if you look at the back of the spindle, that's exactly what we've got. This is the spindle itself. There's a spacer that gets you past a thickness of the wall of the casting, so you've got pressure onto the face of this angular contact bearing here, and you've got an angular contact bearing, a spacer with grease holes in it that are actually in the wrong place. But I think that's because the original grease holes for the greases at the top of the machine were put in for the phosphor or the bronze bearings it used to be in, and they would have probably been oilless, actually, not greases, thinking about it. So you've got an angular contact bearing, a spacer, another angular contact bearing that's opposed to it, and then you've got your nut on the back that then preloads this bearing assembly, these 2, and then at the front end you've got a single deep row ball bearing that's not got any preload on it at all. And that makes total sense, because if you think about the loads that are going on at the front end where the wheel is, they're all pretty much radial. You shouldn't really be putting any axial loads on at the front, so that makes total sense now. So I'm starting to understand this a little bit more. So these bearings, these angular contact bearings, do feel a bit dog-eared. I think that they don't feel particularly brilliant. I've not cleaned them fully out yet, but they're a bit rumbly, and I would imagine they're probably the originals. There's no guarantees of that. They could be refitted, but there's looking at the amount of work the rest of the machine's done, there's every possibility that these are the originals from the 1950s, late 1950s. So what I've ordered is 2 Timken taper roller bearings that are the same section as these in every way, and we're going to replace these 2 angular contact bearings with Timken taper roller bearings, and you know, they're about the best quality that you can get. So we'll preload them up in the same, we'll keep the same spacers, this one, the small one, and the big one, we'll keep the same spacers. That should mean everything fits as it should without needing any modification. And then at the front end, and I've yet to order, I'm going to look for another Timken deep groove ball race bearing to go in the front, and we'll replace this one. I mean, it's okay, it feels alright, but there's a tiny bit of rumbling in it. Not a great lot. I've felt much worse, but so yeah, while we're at it, while we've got it in bits, we might as well do it. So that's the next stage of the process. I've cleaned all the housing up, so we're ready for the bearings to arrive, and when they arrive, we'll just swap all these 3 bearings out with the new Timkens, and we'll keep everything else as it was, and we'll reassemble it. Now, interestingly, the oiler at the back, or the greaser, sorry, at the back, where it actually enters the casting, it enters in the middle of this bearing shell here. So if you're squashing grease in here, it's going to hit this bearing shell. Don't really know where it's going to go then, because there's not really a lot of room for it to go anywhere. So I'm not really sure how this back end was as full of grease as it was, because it would have been a really difficult job for it to get anywhere. And you know, again, the amount of work these bearings are doing, I don't think it needs the greases. They're a hangover from the bronze bearings when it would have been oilers. If we pre-grease the bearings with good grease when we fit them, that should be perfectly good enough for the amount of running this thing's going to do. You know, that's all I've done on the milling machine, and that's doing far more work. So we'll pre-grease the bearings, we'll ignore the greases that are on the top of the machine, they're not in the right positions. So we'll clean all of that out, we'll leave them there because they look nice, but we'll just pre-grease the bearings on assembly, and I'm sure that will be good enough. So if anybody else is doing one of these, hopefully that's a bit of useful information, because the only information I've managed to find as of yet is on lathes.co.uk, and that's led me slightly astray when I started stripping it down. So that's how it should be, and I think lathes.co.uk have got it right. They've just got it the wrong end. They've accurately described this assembly here, but they've said that it's at the front end behind the wheel, which it isn't. And again, as you think about it, the cutting forces, as I said before, at this front end are all radial, so that makes total sense the way this has been put together. So I'll bring you back when we're probably refitting, or whether, you know, I might do a bit more cleanup, but I'll bring you back when we're refitting and putting this all back together. Right guys, we're going to make a dresser for the grinding wheel on the surface grinder. So I've had a quick look through my stock. This is kind of the nearest thing, stock wise, roughly the kind of shape that I was going to end up with. It's got a hole in that I don't need, but doesn't matter. In fact, I might even plug that with something just to stop the dust and stuff getting in there, so that I don't have to keep cleaning it out. So I might do that. But you can see this, whatever it's been used for, has had a miserable life. That's obviously been trapped between something. It's all mashed up. Same on this end, it's been whacked with something. Same on this side, again, all mashed up pretty badly. And over the whole thing really, there's just lumps and bumps missing out of it. Don't know what this was, where I got it from. It has got a bit of John's Workshop on it. This was me messing around with the engraving machine until I realised that the head is absolutely shot on it, and that's why it doesn't engrave properly. So what we'll do is clean this up, and I've just been trying to work out which face to start with just based on how mashed it is. So I've cleaned this top face with a file. It's pretty flat, and these two areas here are fairly good and fairly parallel, so we're going to start gripping on that bit. We'll clean this bottom face up, then we'll sit on there, clean the top face up, and then we'll just flip it and clean the other ends and the sides up till we've got it looking nice. So I'll stick that in the vise and we'll get going. Right guys, next job on the dresser is to put the industrial diamond in. So industrial diamonds have turned up. I'm not quite sure of the quality. Cheap and cheerful from our friends. So let's have a look. Well, let's hope the let's hope the adhesive that's bonding the diamond together is a bit better than the adhesive that's bonding the box together, eh? Let's see what we've got. So there we go, a diamond pen, brazed in industrial diamond in the top there. So it's supposed to be 11mm shank. We'll just give this a bit of a look and see. Or maybe it's a 10mm shank. Maybe it's not even that. I think 11mm must be the, it was sold as 11mm, but that must be the major diameter at the top here. We'll check that in a minute. So on here we've got 9.5, 9.51, 9.49, sorry, 9.497, 9.501. Yeah, so that's not particularly round. It's been turned, but I'm not sure what they turned it on. There's probably about 6 microns out around, I would think, on that. So I need to try and pick the middle range of that. I'll have a look and see if I've got a reamer, but if not, we'll just be drilling this. Let's just check this major diameter, which looks like it's been ground as opposed to turned. Oh, maybe not. 11.2, At least that is round. 11.2 pretty much all the way around. So yeah, I'll have a look at my reamers, see what size I've got that's close to that. If not, this is going to be just a drill job, and then what we're going to do is hold in the collet block on this end, and we're going to machine a flat on this diameter piece for a grub screw to bite into. We're going to drill and ream, if I've got a reamer, a hole in the block, drill and tap a hole this way for a grub screw to bite into the flat that we machine, and then that will complete this off. So I'll just get some tools together. Right, not sure how this is going to go. So the pin, the dressing pin measured 9.50304. I've had a look through my reamers. I found this one, it's 9.50506, so it's a tiny bit big, but it doesn't feel very sharp. It doesn't look very sharp. So we'll give it a go and see what happens. Well, it's cut. Looks like a reasonable finish. We'll just try that out. That'll do. Good enough. So we'll countersink that, reset back up, and drill and tap the side hole. Go nice and big to save myself a countersinking operation, hopefully. There we go, guys. That's got the wheel dressing block all finished off, blacked up, assembled, and that's ready to go. Right then, guys, on to the electrics. Because this channel's all about trying to pass on experience, good and bad, so I'll walk you through what I've done and my thought process and my assumption that's led this to become quite a bit of a trial really, if I'm honest. So you'll have seen in the first episode I was struggling to get the converter to run the motor, and I wasn't sure whether it was the motor or the starter box or the motor or the converter or the tightness in the spindle, all of which has led me to stripping the entire spindle down and replacing the bearings, which I think, to be honest, I'm pleased I've done that anyway. So that's the first thing. Secondly, I stared at all the options, did a bit more research, and I found out that my static phase converter, they don't play nicely with these starter boxes for a start, and secondly, and the reason for that I think is you've got dual switching, so there's some switching going on in the static converter and there's also some more switching going on in the starter box, and the two things just don't agree with each other. I think that's part of the problem. Secondly, my static phase converter has got a minimum motor size or power drawn size of 1 kilowatt, which I think is about 1.5 horse, something like that, horsepower. The motor on this machine is a 1 horsepower motor, which is about 3/4 of a kilowatt. So even at the lowest setting on the phase converter, I'm putting too much juice into the machine. So all of those things combined means that for a 1 horse motor, 3/4 of a kilowatt, it's just not really compatible with my phase converter, and certainly the switch box isn't convertible with the phase converter. Now, to be fair, the guys at Tools for You watched my first video. I did forward them the link, and I've got to be honest, they've been incredibly helpful. Sent me a few emails back that I've not responded to yet, but the guy got straight back to me yesterday, having seen the video at the weekend, and said, look, if you're ever having trouble, if you buy from us again, if you're ever having trouble with deliveries like I did with the Pallet Line UK, don't call them, call us and we'll fix it for you, we'll get things sorted. And then he also said, I've seen you having trouble with your electrical stuff, and it was him that pointed me out to the fact that the starter box probably isn't compatible with a phase converter. And again, I'm a complete numpty when it comes to certainly 3-phase electrics, so I've just got to take any advice I get and kind of go, does it pass the straight face test? And what he told me sort of passes the straight face test, if I'm honest. So, and he said, we've got an electrician on hand, if you're struggling, give us a ring, we'll talk you through it, we'll help you out. So again, the guys at Tools for You, couldn't be more happy with the service I've had from them on this. This has been really good. So what I'd already made a decision by that point that with enough research that I needed to do something different. So I thought, I'm going to go down the VFD route, variable frequency drive, because there's many reasons why that was the best option. It was probably the cheapest option for a start. It's turned out not to be the cheapest option, but you'll find out why. And it gets rid of two things fundamentally. It gets rid of the starter box being an issue, and it also gets rid of the phase converter being an issue. It wipes both of those things off the map, so then I'm only really concentrating on the motor itself. So I ordered the next thing I did was started to look at the motor, and I was going to rip the motor out the bottom of the machine, get it right out, put it up on the bench, and because this machine is so original, all of the nuts and bolts that hold the motor into the motor plate in the bottom of the machine are all Imperial, and I really needed sockets to get to the underside. I couldn't get spanners in, even if I had spanners, and I've got no real Imperial spanners the right size, and I didn't want to start rounding nuts off and making a mess of it. So I thought, oh, do you know what, I'm just going to leave the motor in there. I've looked at it and it looks fairly modern. It was a Brook Motors, it was a Griffin motor. Did a bit of research, wasn't sure what model of Griffin, couldn't see that with it in the bottom of the box, so did a bit of research, looked at the motor and I thought, that looks pretty new. I'm sure that motor, and here's the assumption, will be able to run in both star and delta mode, which means if I buy a VFD for it, I've just got to change the jumpers over, no bother at all, off we go. So I've ordered my phase converter, sorry, my VFD, which has now arrived for the size of motor on the machine. The day after that, I thought, I need to get the motor out anyway, because I forget the reason, it was through the wiring or something, so I thought, I'm going to have another go at this. So I moved the machine then to a better location where I could get better access, managed to get the bolts undone, no problem at all, got the motor out, slid the little electric plate off the back where the wire goes in. Guess what? You can't have it in star or delta. So I've now got a VFD that I can't connect to anything because the motor doesn't accept it. So I'm then thinking, oh God, what do I do now? This is stupid, I'm just chucking money away. So anyway, long and the short of it is, we've now got a new motor as well. So brand new motor, 3-phase, cheap and cheery really, it wasn't that expensive. Got the 3-phase converter, sorry, the VFD. What that means is I've now got a spare 1-horse motor, 3-phase, and a starter unit, and I'm going to keep hold of those because I've got a plan for both of those things at a later date for another machine tool. And I know they won't work with my static phase converter, but by that time I may have either converted that static to a rotary or changed it out for a rotary, and I'm talking not in weeks or months, I'm talking probably in a couple of years down the line. So I've now got a motor and a starter box that will work well, I think, with a rotary phase converter for another project later on. So it's not lost. It just feels like it's ploughing money into this thing, but it's not lost. So I've got the bearings have turned up for the head, so we're now into reassembly time. The only thing I need to do different is the new motor's got a bigger diameter shaft on it slightly than the old motor did, and so I need to get the pulley off the old motor, get it up on the lathe, clocked in, probably do that in the 4-jaw, and bore the centre of the pulley out, put a new keyway into it, which will be interesting because I've never done one of those here in this shop. I've done plenty in industry, so I need to find a method of doing that. We'll probably try and do that on, well, either the lathe or the mill, I'm not sure yet. We'll have a go at seeing how we can do that. It's only aluminium, so it should be fairly easy to do. And get the motor mounted. I think I'm going to do the motor first, get that in the machine, mounted in the right place, and then we will then focus on the top end, rebuilding the bearings and rebuilding the top end of the shaft. So once all of that's done, this should be perfect. Brand new motor, all new bearings in the top end, a VFD, meaning I can have a slow start to the wheel. But and again, some of the feedback from Tools for You was that they're not too keen on VFDs where people are trying to use them for variable speed, especially on grinding wheels, and I absolutely agree with them. Grinding machines are meant to run at a fixed speed only, and I will be doing that. I'll be running it at the full speed. So this motor's got the same speed rating as the old one. It's 2,800 RPM, and I'm going to be running at that full speed as it's intended to run through the VFD, but I'm just going to have a slow ramp so that I don't get the inertia kick when I start the wheel. So all good. I'll bring you back in a bit when we're starting to put some of the new bits in and rebuilding the machine. So guys, my assumptions have just led me to just more and more work, and it was kind of too, well, it wasn't too late. I could have sent stuff back, but anyway, the motor I bought, and again, not being an electrician, not really knowing what I was buying other than obviously the size of the motor and the fact it was 3-phase and the fact that it would do star and delta, which is all I thought I really needed to consider. As it turns out, that's not all I needed to consider, because the mounting plate that I didn't really understand was different motor to motor, and if I'd have given it some thought it would have made some sense. So when I offered this up into the bottom of the machine, it obviously didn't fit because I'd bought the wrong one. So I could have sent it back, fannied around, boxed it all back up and sent it off and waited for another one, and had all the hassle of posting it. And but again, because of where we live, it's so rural, it's not easy, that kind of stuff. We haven't got a post office 2 minutes down the road to do that kind of stuff, and I'm not that savvy with delivery people coming to pick stuff up. So I just thought, I've got a workshop, I'm just going to make it fit. So you can see it's now proudly wearing its new set of skis on the bottom, and these have been made and designed around the plate that's in the machine, in the bottom of the machine that this sits on. So I've not made any adaptations to the machine whatsoever. I can always put the old motor back in place at some point in the future, so there's no change to the machine itself. So this is all ready to go back in now, other than I need to attach the wiring before we do that, and I've just got the pulley off the old motor on the lathe. We've got it bored out to this new shaft diameter, and I'm just busy popping a keyway in. I may film some of that in next week's episode, because that's something a little bit interesting, something I've never done in my home shop before. So, and as yet, no real idea how I'm going to do it. So that'll be for later in the week when I decide how I'm going to attack that. So I will bring you all back at some point next week, when hopefully there's some light at the end of the tunnel now. I think I'm through all of the headaches that are presenting themselves one after another, so I think I've got everything where I need it now. This is ready to slide back in, fitted in place. It's actually worked out quite well, because the centre line of this motor was about half an inch lower than the centre line of the old motor, so by putting these two ski pads on the bottom, it's lifted it back up to exactly the same centre height, so that's worked out quite well. So as I said, that's ready to go back in. I've got all my bearings ready to go to be fitted on the shaft. That's the last thing I'm going to do once I've sorted out all this faffing around with electrics and stuff. So once I've got all that done, and there's a lot of just spanner work inside the machine. Even if I set the camera up, you're going to struggle to see what I'm doing, so I'll show you when I'm done it in place, and then I will film for next week the reassembly of all of this main shaft line with the bearings, and hopefully next week we'll have this thing powered up and we will be back to somewhere near where we need to be able to get the machine back in position, level back up again, and then we can hopefully start taking some tentative cuts on it. So I've got my wheel dresser ready to go now as well, which is good. So thank you all for watching my my foray into stupidity. We will catch you all at some point next week. Thank you to the new subscribers that have come along. Just a fantastic response to last week's video for whatever reason. I don't know whether it's the fact it got surface grinder in the title, I really don't know, but it obviously appealed to a lot of people. So, and I've gained quite a few new subscribers as a result of that, so really appreciative of that. So thank you to the new subscribers that have come along, and hopefully we'll gain a few more this week as they all have a damn good laugh at my stupidity. So thank you to you all for sticking with me, and we will catch you all at the same time next week, when hopefully we'll be putting this thing back together properly and switching it on and getting into some proper grinding. I'll put the front of the switch back on, we're powered up. If I press go now, nothing happens. We'll start all that again, because that was shit.